private key of the receiver. Then what you should do, decrypt this, extract the certificate. What will you do to extract things from the certificate? The certificate is nothing but what?
Verification.
Public key certificate is?
Verification, like a notary.
Yeah, so what will you do with it? How can you extract the information from the certificate?
You need a public key
You need
from the receiver.
public key of the certifying authority, because the public key certificate is the public key of the user encrypted with what? The private key of the certifying authority. So you need the public key of the certifying authority to get the public key of the user. So you go through that process. So that will be the fourth step. So you decrypt with the public key of the certifying authority, extract the public key of the user, of actually the sender here, and then use that to decrypt this to get the encrypted hash value. So that will get you the hash value. And then for the message, you compute the hash value. The two hash values should match for integrity. Or you can also say for authenticity, right? Because if it was signed by someone else, the hash value that you get here will not match with the hash value that you compute for the message, like we did for the PGP case. Okay? So same idea. Okay, so from the first two you get the actual message that you're supposed to receive. So now we want, so that provides you confidentiality, because you could decrypt this only with the session key, and session key was encrypted with the public key of the receiver, known only to the receiver, right? To decrypt it has no private key, right? Now you want to check for authenticity. Authenticity means what? You want to make sure the message came from the particular sender. So for that, what the sender had done, the sender has computed the hash value encrypted with its private key, right? So it's like a signature. Now to decrypt this, the sender has sent its certificate, but it did not send its certificate in the open. It encrypted its certificate with the public key of the receiver, so only the receiver can decrypt with its private key. So this is where the additional complexity comes. So now the receiver has to first do what? Decrypt with its private key to extract the certificate. And then, so this is certificate of whom? The certificate, public key certificate of the sender. So any public key certificate is nothing but the public key of the user encrypted with the private key of the certifying authority. So that's what makes like your signature, because nobody else can sign for certifying authority, right? So it's like a notarized version of the public key. So now the receiver has to decrypt this certificate with what? With the public key of the certifying authority to extract the actual public key of the sender. So using that public key of the sender, it has to decrypt this portion, because this was encrypted with the private key of the sender, right? So it can decrypt this with the public key of the sender to extract the actual hash value. And this hash value is computed on the same message that was sent. So the two hash values, so if I recompute the hash value on the message I got, this hash value should match with this hash value, because it is computed on the same message. So in case it was changed during transmission, either by the hacker or by due to some natural factors, the hash values should not match. So that kind of tells the sender that the message was changed, got changed, and it more likely might not have come from the particular sender. So sender will drop the receiver will drop the message. But if nothing like that happens, the two hash values should match. And that provides you the authenticity, and implicitly provides you integrity also. Because if it has changed during transmission, the hash values should not match. So authenticity and integrity always go together once you start using the hash value and encrypt with the private key of the sender. Okay? Because once you encrypt the hash value, the private key of the sender, it means when the sender has sent it. And if you get the message and to recompute the hash value should match. Otherwise, it has changed. The message has changed. Got it? I will go through it a couple of times, but this is the order in which it was decrypted and you get the message.
So the section key here is like a secret key.
Right. The session key is like a secret key. It could be used on a per session basis or for every message you could generate it because you are sending it along with the message, so you could generate it for every message. There's no need to maintain it for a whole session. Okay. Alright, so this is the second standard. The third standard is not that common because users don't use it. It's mainly used by the domain administrators. So it's called domain key identified mail. So this is used for sending emails. Again, because that's the whole topic about email security. So, so the idea is the message that you want to send is encrypted not with the keys corresponding to the user level. It's encrypted using keys corresponding to the domain authority. So it could be like a domain administrator, okay? Normally email administrator. So at the sender side, there is someone, say, a mail submission agent. Okay? So the mail submission agent is nothing but the domain administrator at the sender side. So the message is encrypted with the, if you just want authentication to keep it simple, what we do there, we encrypt the message with the public, private key of the sender, right? Remember in PGP and S9, that's what we do. We encrypt the message with the private key of the sender and send it. So this is as simple as that. You can send along with the message, right? You could compute the hash value or don't need to compute the hash value, it's up to you. So this provides you authenticity, right? It's like a digital signature. So instead of using the user's sender's public private key, we use which person's private key? The mobile mail submission agent, the kind of domain authority. Okay? So all the emails going through that network, through that domain, will be signed by that domain authority's private key. Right? So at the receiving side, again, it will be decrypted at a domain authority that will be called the mail delivery agent or the message delivery agent. So this person has to have a database of the, because it was encrypted with the private key of the mail sending agent, right? So it has to know what? The receiving person has to know what?
The key?
The public key of all the domain authorities. So it have a database of the public key of all the domain authorities. Okay? So this is more manageable because you don't need to go through on maintain records on a per user basis. You go maintain records on a per domain basis because all emails go through that same authority. Okay? Now, if you have heard of this DNS in a networks class, what do you do there? Domain name service, right? So, for example, if you want to visit a website, internally, your machine needs to know its IP address, the web server's IP address. So what the machine does is, it goes through this DNS domain name resolution process of trying to identify what's the IP address of this website domain name. So like that, if you get an encrypted email from a domain and you don't know the public key of the domain authority, you query someone else, like the domain name authority, to find out what is the public key of that domain. And that person will send you the public key of that domain. Okay? So I simply state that you use DNS to find out what is the